these complex numbers. Okay, 3 times 5 is 15. 3 multiplied by 4i is 12i. 2i times 5 is 10i. And then 2i times 4i is going to be minus 8i squared. Okay, now with complex numbers we have one little extra tidbit we have to keep track of, that I squared is equal to -1. So this right here is one of those I squareds, and so that's going to become a -1. So what do we really have? 15 minus 12i plus 10i would be minus 2i, and then the -1 and the -8 is going to become a +8. So the final answer we would give would actually be 23 minus 2i after full simplification. Okay, let's try it again. 7 multiplied by 2 would be 14. 7 and 3i would be 21i. 6i and 2 would be 12i. And then in that last place, looks like we have a minus 18 with an I squared. Again, I squared is the number -1, so we would be getting 14. 21 minus 12 would give us a 9i, and then the -1 times the -18 would be +18. So our final answer here would be 32 plus 9i. Okay, why don't you pause the video, try this one out for size, and see what answer you get. There's a little surprise on this one, by the way. So, assuming you gave it a good shot here, 5 times 5 would be 25. 5 times 4i would be 20i. Again, 4 times 5, so 20i. And then here we'd be getting a minus 16i squared. So no shocker yet, right? The I squared is still a -1. But the neat thing is that those middle pieces cancel each other out. So what do we end up having is the 25 in the first place. -1 times -16 means now we're going to have a +16. And so the final answer to the product of these two complex numbers was a real number, namely 41. These are called conjugates, and that was a neat simplification that we'll use when we divide complex numbers.